DF-17, the hypersonic edge. A flash of heat. A silhouette racing across the upper atmosphere. Not a ballistic arc, not a cruise missile, something in between. Maneuvering. Hard to track. This is the DF-17, China's road-mobile missile married to a hypersonic glide vehicle. A new kind of strategic arrow in a very different era of warfare. What is the DF-17? The Dongfeng 17, or DF-17, is a Chinese medium-range missile system designed to carry a hypersonic glide vehicle, often reported in open sources as the DF-ZF. Unlike a conventional ballistic re-entry vehicle that descends on a predictable arc, the DF-17's glide vehicle separates at high altitude and then travels through the upper atmosphere at hypersonic speeds while maneuvering toward its target. How a hypersonic glide vehicle works. Hypersonic glide vehicles are one of two main hypersonic categories, the other being air-breathing hypersonic cruise missiles. HGVs are boosted by a rocket to high altitude and speed. They then glide through the upper atmosphere at speeds above Mach 5, enduring intense heating and plasma effects, while executing evasive maneuvers. This makes detection and interception more complex than with traditional ballistic warheads. For the DF-17, the booster appears similar to other medium-range solid boosters. The breakthrough is the HGV itself, built to survive extreme heat and to maneuver during the glide phase. Development and testing history. The DF-17 evolved from tests of earlier glide vehicle prototypes. Western and Chinese reports trace DF-ZF test flights back to the mid-2010s. Multiple flight tests through the late 2010s refined the vehicle's ability to separate, survive plasma heating, and maneuver at hypersonic speeds. By the late 2010s and into 2020, the DF-17 moved from experimental tests toward operational demonstrations and limited deployment. Technical snapshot. Open source estimates put the DF-17's range in the medium-range bracket, roughly 1,800 to 2,500 kilometers depending on launch parameters. During its glide phase, the DF-ZF HGV has been reported to reach speeds in the general Mach 5 to 10 band. Exact performance figures are carefully guarded, and public numbers are estimates based on telemetry, observation, and analysis. A mobile launch platform. A key part of the DF-17's operational concept is mobility. Mounted on a transporter erector launcher, a multi-axle road truck, the system can relocate, disperse, and present multiple launch points over a wide area, complicating preemptive targeting. This mobility, together with the high-speed, maneuvering HGV, gives the system strategic and operational flexibility. Why hypersonics matter? Hypersonic weapons change the calculus for missile defense and deterrence. Their combination of speed, maneuverability, and high-altitude flight reduces warning time and complicates tracking and intercept solutions optimized for predictable ballistic trajectories. For regional scenarios in the Western Pacific, analysts argue systems like the DF-17 are designed to hold at risk forward bases and high-value naval units. Strategic use cases. Military analysts suggest roles for the DF-17 include precision strikes against high-value fixed targets, anti-access missions aimed at naval task forces, and the targeting of air bases and logistics hubs to deny an adversary freedom of movement. Because the glide vehicle can maneuver, it may be tasked against moving or relocated targets within certain constraints, though real-world effectiveness depends on target sensing, battle management, and timing. Challenges in defense and detection. Hypersonic weapons are not invincible. Their high speeds and plasma effects create tracking challenges, but they also pose engineering demands, extreme thermal loads, complex guidance and communications through plasma sheaths, and the need for advanced sensors and interceptors to respond quickly. Nations worldwide are racing to field both hypersonic weapons and layered defenses to detect, track, and, if necessary, intercept them. How nations respond. The arrival of HGVs has spurred countermeasures, improved space-based and over-the-horizon sensors to restore tracking, faster interceptors, and new command and control solutions to shorten decision cycles. For navies and air forces, this means repositioning, dispersal, and layered defenses are increasingly important. The technological race is not only about missiles. It's about sensors, computing, and industrial scale, political and strategic implications. Weapons like the DF-17 do more than change battlefield equations. They change geopolitics. They raise the stakes of regional crises, feed arms race dynamics, and shape alliance decision-making on posture and deterrence. For some states, hypersonic capabilities are a lever of influence. For others, a new risk to be contained through diplomacy and resilience. What's next? The DF-17 is part of a broader wave of innovation. Whether this becomes the dominant model of future strike systems depends on cost, reliability, and integration into larger military architectures. We can expect continued testing, incremental improvements, and international responses in sensors and interceptors. The next decade will tell whether hypersonics reshape deterrence or become one more capability in a crowded toolbox. Final thought. Speed changes everything, not just how fast a weapon travels, but how quickly nations must see, decide, and act. The DF-17 is a symbol of that change. Fast, elusive, and forcing the world to rethink the geometry of defense. For citizens and policymakers alike, the race for hypersonics underscores an old truth. Technology can shift the balance in an instant, and governance must keep pace.